All right, let's take a look at your next lesson, which is called More Two-Step Equations. Heading up to your learning goals, we're going to be doing learning goal 31, which is being able to solve trickier two-step equations, including the distributive property. And so let's go ahead up to here, and you can fill out number 31. Okay. All right. Scrolling down to that lesson, get rid of the page sorter, and here we go. All right, the first step here to solving an equation with more than one variable, remember we are going to reverse PEMDAS and undo PEMDAS. So reverse and undo order of operations. Now, there are some other little rules that we're going to talk about as we go here. But let's go ahead and kick off a review of order of operations. So when we would be solving something like this, let's think about the do side of this, okay? The first thing that we would do is what's inside the punctuation. So inside this punctuation is a subtract 12, and then we would take care of the multiply -4. Okay, if we were to undo that, we would go backwards through that process. Let's go ahead and look at this one. Okay, so I see the punctuation here. So my thing I would do first, within the punctuation, if we're thinking PEMDAS, is the multiplication. So the times 3 first, and then the add 11. Okay, and then after that, I would do the times -5. So if we were to undo that, we could go backwards through that process. Okay, all right. Now, I'm going to give you a couple little tips. Just knowing what I know about future math for you. So when we see this one, we can identify that we have the distributive property available to us. We don't really have to use it with this. We could do the reverse and go ahead and just divide by 3 to both sides. But I'm actually going to recommend doing something else, just because when we get into more complex problems with maybe some more distributive scenarios on both sides of the equal sign, the just divide by 3 plan gets a little bit more complicated. So I would recommend number 1, if you see this distributive type of problem, go ahead and distribute. And then at the same time, number 2, I would probably combine some like terms and then do reverse order of operations to solve for x. Okay, so that's what we're going to do here real quick. So do a quick distribution of that 3, and we get our 3x plus 15 equals -6. And now we're going to do our addition subtraction first, which remember, if we're looking at PEMDAS and going backwards, we would start back here and go this way. So addition subtraction would be first. So I'm going to go ahead and separate my space here. We'll go ahead and do the inverse operation here and undo the add 15 by subtracting 15 to both sides. When we do that, we create a 0 pair, and we end up with 3x equals -21. And then we're going to do the opposite of the 3 times x and divide 3 by on both sides. Once we do this, we create one whole, and with the identity property of multiplication, we're just left with x equals -7. Let's go ahead and do our check. I'm going to go ahead and do it in black as a reminder to write everything in black the way it is. 3 times the quantity of -7 plus 5 equals -6. When I go ahead and solve this out, I'm going to go ahead and do my parentheses first, or you could distribute. Both will get the same thing. But I'm just going to follow order of operations in here now. 7 plus negative 7 plus the 5 gets me a negative 2. And bring everything else down. Now I have the 3 times negative 2 is negative 6 equals negative 6. And so this checks out. All right, let's go over to here. I see that I have a distributive property available to me. So I'm going to take care of that first. I am going to KFC that as well. All right, and let's go ahead and distribute that too. So we end up with a 6z plus 2 times a negative 2 is a negative 4 equals negative 12. Now I can go ahead and do the reverse order of operations to undo this. Okay, so we're going to, instead of having a minus 4, I'm going to add 4 to both sides. That creates a 0 pair, so I end up with 6z equals negative 8. And then I can go ahead and notice that we have a z times 6, so I can divide 6 on both sides and end up with a z equals negative 8/6. If I wanted to simplify that, I could, and divide both by 2 over 2, and we end up with negative 4/3. Okay, and so that's what our z equals. Let's go ahead and check. So I'm going to go change to black since I'm in that check mode. 2 times the quantity of 3 times negative 4/3 plus a negative 2. And then we have equals negative 12. So let's go ahead and take care of inside the punctuation first. So I have a 3 over 1 times a negative 4/3. I can cross simplify that, and it just gives me a negative 4 plus a negative 2 times 2 equals negative 12. Then I can solve those, and we get a negative 6 times 2 equals negative 12. And then we have a negative 12 equals negative 12. And that checks out. Okay. All right, let's go to here. There's no distributive property options going on. We just have a nice simple two-step problem. Remember, our goal is to get x by itself. And so let's look at what's going on with the x. So I have an 18 minus x. And so we're going to go ahead. One strategy you can use is to actually sort of cover up this and just sort of see what you see. So I just see a positive 18. With that positive 18, how would I undo that? I would subtract 18 from both sides. Once I do that, that created a 0 pair. And just be aware that you have a negative x. We do want to make sure that we're aware of our 1 there. And so we have a negative 1x equals negative 20. And then we need to go ahead and get rid of the negative because we want just a positive single x by itself. So divide by a negative 1 on both sides, and we end up with x equals 20 because the negative divided by the negative. Okay, let's go ahead and do our check now. We're going to plug everything back in. So we have 18 minus x was 20 equals negative 2, and this is a nice easy one to solve. If I KFC that, we can see that we have negative 2 equals negative 2, and that checks out just perfectly. All right, let's take a look at number 4. Number 4 does not have any distributing, no combining like terms first or anything like that. So let's do the reverse order of operations, which is taking care of any addition subtraction. So I have a positive 2 here. This is all multiplication here, so that'll be last. So let's go ahead and separate our two sides there. And instead of a positive 2, I will subtract 2 from both sides, putting them right underneath. Creates the 0 pair, and we are left with now a negative 6x equals a negative 2. Now I can go ahead and look at the fact that I have a negative 6 times x. So the inverse operation would be to divide by negative 6 to both sides, which leaves us with x equals negative 2/6. Negative times negative, though, is a positive, so we are just left with 2/6 here. And if I simplify this, we end up with 1/3 as an answer. Okay, and so x equals 1/3. Let's go ahead and check. And for our check, we have 2 minus 6 times whatever x is, which is 1/3, equals 0. Okay, order of operations now. I do my multiplication first. So 6 times 1/3 is 6/3. And so when I do that, you can cross simplify because technically we have a 6/1 times a 1/3. I can cross simplify those and get a 2 here. So we end up with 2 minus 2 equals 0, and thus 0 equals 0. All right, last two. Okay. So we have fractions now, which can be a pain, so just slow down with it and really pay attention to what's going on. So here is my D term that I'm going to be isolating. So we're going to address the subtraction first. Okay, so let's separate our two sides as we normally do. So instead of subtracting 3/2, I would add 3/2 to both sides. Okay, luckily we have common denominators, which makes things a little bit nicer. These will cancel out and create a 0 pair. And now we have negative 1/2 plus 3/2, which now gives us a 2/2, which I can just erase that and say that we have 1 whole on this side. Okay, on the left side, I still have, let's do your rewrite, 5/2 d. Okay, now to get rid of my 5/2 d times d, I would just divide by 5/2, but we don't divide by fractions. We multiply by the reciprocal or the multiplicative inverse and multiply by 2/5 to both sides. Okay, that means that's gone, and we have times 2/5. Well, because of the identity property, that means d equals 2/5. All right, let's go ahead and check our work here. So we have 5/2 times 2/5 minus 3/2 equals negative 1/2. Okay, so let's go ahead and multiply these across. We know that 5 times 2 and 2 times 5 is going to equal 10/10 or 1 whole. Okay, so we have 1 whole minus 3/2 equals negative 1/2. And so if I have 1/1 and we multiply this by 2/2, this technically ends up being 2/2 minus 3/2. So different signs subtract, 3, 2, 1. We end up with a negative 1/2 equals negative 1/2. Okay, and that checks out, so we know that we did it correct. All right, and here we go. Let's go ahead and look at your last one. You can even pause the video and try it on your own and then hit play when you're ready. All right, separate our workspace here. My entire variable term is right there, so that means I'm doing that last, and we're going to address this 2/3. Pay close attention and notice that it's not 2/3 times anything, it's just an addition subtraction, and so we just have a positive or a plus 2/3 sitting here. And so to do the inverse operation, we're going to subtract 2/3 from both sides. Okay, now I don't have common denominators, which doesn't affect this side, but it does the right side. So let's go ahead and do our rewrite here real quick. We have negative 6h equals, and then we'll go ahead and make common denominators. So times 2/2, and we end up with a negative 4/6. So we have a negative 11/6 and a negative 4/6, which puts us at a negative 15/6. All right, moving on to our next step. We want to get the negative 6 away from the h, so it's a times. So we'll divide negative 6 to both sides. And instead of dividing by a negative 6, we could multiply by the reciprocal since we do have a fraction. So let's go ahead and do that instead. So this is negative 6/1. So I can multiply by the reciprocal, which would be multiplying by 1/6. And so let's go ahead and that gets rid of this, and we're left with h equals, and then we'll multiply by 1/6. Okay. Now that we do this, we can look and see if we can cross simplify to make things a little bit easier. So I can see that I can cross simplify these by dividing by 3. So I end up with a negative 2 and a negative 5 here. And so if we multiply straight across, we end up with h equals negative 5 over negative 12. The negatives divided by a negative goes away, and we're just left with 5/12. Okay. All right, let's go ahead and do that check. So doing everything in black here, we have the 2/3 minus 6. Since I know it's a fraction, I'm going to do minus 6/1 times 5/12 equals negative 11/6. Okay. Order of operations says that we will do our multiplication first. So we end up with 30/12. Bring everything else down. Okay. I don't have common denominators here. So I have to make common denominators to do this subtraction. Let's see, can we divide both of these by 2 to make 6? So let's do divide by 2/2. So I end up with 15/6. Let's go ahead and times 2/2 to get 4/6 equals negative 11/6. And then with our KFC there, you can see that we end up with negative 11/6 equals negative 11/6. That was sort of a pain in the butt one, but it all checked out. So there we go. That is more two-step equations, getting a little bit even more complex. You can see it still follows the same process, other than that little suggestion of distributing and combining like terms before then working backwards if the problem allows for that.